Welcome to Dakota Starry Nights. I'm Richard Walker. Now wouldn't it be great to have an observatory set up right here? What a view! Or how about here? This would be a great place for an observatory. Yeah, this'll work too, but they gotta fix that elevator. I think I found what we've been looking for. That's Black Elk Peak behind me up there. And that, ladies and gentlemen, is the highest peak east of the Rocky Mountains. But I know a shortcut, so what do you say we go up there and check it out? Black Elk Peak, the heart of the Black Hills. Dark skies and unobstructed views. I'd say you see a star or two from up here, but for most people a backyard is all they got to work with, and that's if they're lucky to have a backyard. But the problem with the backyard is the view, or to be more precise, the lack of one. Oftentimes there's a street pole or house or some other barrier that makes putting up a permanent observatory not very practical at all. So if you can't bring the view to the observatory, why not bring the observatory to the view? Ladies and gentlemen, I give to you the mobile observatory. Check it out. It's lightweight, it won't rot, and it blends in the background. Got a little bit of U.S. Army OD green here. It's affordable too, and most importantly, it is mobile. Typically, a guy will spend weeks or months imaging one target, and oftentimes there may be just one small section in your backyard that's clear of obstacles to allow for data acquisition of that target. Roll the pod in place, set up your imaging platform, and leave it there. When you're done, you move the pod to another backyard location for the next project. So now let's think this through a little more. You know, with wireless connectivity and mini PCs, a large hardwire permanent observatory is really no longer necessary for the amateur astronomer. What's needed is something small and light enough to be mobile, but large enough to house an imaging platform, with some room for a small chair to sit on while you're doing the initial startup. After that, grab your laptop, go back to the comfort of your home, and do your imaging wirelessly from there. Now this pod, originally designed as a hunter's blind, but now converted to a mobile observatory pod, checks all those boxes. So let's have a closer look. All right, for the mobility part of this, what I'm doing, I'm taking a treated 2x4 and I will be mounting the wheels to the outside. Now this line here represents where the hunter's blind intersects the 2x4 on the outside. It comes like that and then the wall goes like that. And so I've measured 5 inches from where that intersects out in order to give the wheel clearance when it's hung out here to where it doesn't interfere with the side of the hunter's blind. And this is basically a bolt. It looks like 5/8. Your mileage may vary depending on your wheels. And there's a bearing already in there, so put that in there like that. I put 4 of these big washers. This has been drilled out with a 3/4 inch Forstner bit, but you can use any kind of bit as long as it's 3/4 if you're using this size bolt, right? The idea is to put this here like that, lag screw it from the bottom up to here, and then put a gusset here to support the sides. Now you can't come out further than right here with the gusset because otherwise it's going to interfere with the wall. So the gusset will come up to here to give this support. This doesn't have to be, you know, designed to go down the interstate. Remember that, guys, because you're going to just be moving this around your backyard. You're not taking it on the highway. So this will be like this, okay? This will be permanently attached, but the wheel will not. All you would do would be to unscrew your wheel, and now this stays like this, okay, on the outside, and that's always there. So, okay, and then that will allow the observatory / hunter's blind go down to the ground, and all of the 2x4s that are going to be on the inside of this pentagon to give it support and rigidity will be flat on the ground. The point being that the wheels are temporary because you'll only use it whenever you need to move the observatory to avoid the house or the tree or whatever it happens to be. Okay, so I'm going to be using these lag screws. These are like 3 inches. You could use 3.5. You want to clamp it together so your pilot holes match up. And this is, I'll be drilling it down from this end, and then this will go in like that and then like that. I think what I'm going to do too also is countersink this a little bit so this head doesn't stick up above the ground and start scraping on the ground when I go moving it around. Okay, from the bottom it's 4 inches on center. That'll vary depending on the diameter of your wheel. You probably want at least 3 inches of ground clearance, maybe 4 depending how rough your yard might be, but keep that in mind when you go to set this height. One other thing, when you go to countersink, make sure your countersink hole is big enough to allow the socket to go down in there and snug up the lag screw. Now that we've got the corner braced in here, and I've got a steel brace back here to give this extra support, this is pretty solid though. We'll put the wheel on, and this comes off like that. Now if you need help lifting this up, by all means get the help, because you don't want to be, you know, straining yourself. I'm going to grab the brace here to lift it up. It slides right in there. There's a brace like that, and I just put my hand in there like that and lift it up from the brace. Gives a nice hold. So we got that one on. This thing is light, it's not that heavy, but, you know, depending on your strength and condition, your health condition, you know, keep that in mind. You don't want to, you know, strain yourself. So if you need help, get it. Okay, I put a nice D handle right through
the 3/4 inch stock that I got on the inside and used the same T-nuts with these bolts. Utilized one of the natural holes that were in here and put it here. I figured this is about the right height to where you can keep your arms straight and just give it a lift up. Guys, this is it. I haven't tried it yet, so we're all in now. Let's see what it'll do. Oh my God. Oh yes. Look at that. Oh yeah. Hell yeah, baby. I love it when a plan comes together. Look at that. Yeah. All right. So the best way to get your dimensions for your frame is on the back of the cardboard carton that this comes in is a template to allow you to cut a plywood floor. So basically you could use that template as a guide on how to frame this out. Just be sure that this is centered on the 2x4. Remember that that template is for the inside and we want to be on the outside a little bit. And that's about the easiest way to get your lengths for your Pentagon base. Now you don't have to go with this if you just want to scoot this around and shove it around, but because I'm putting wheels on it, I need some kind of a platform in order to give this support while I wheel it. Okay, so what I'm doing now is I'm putting these straps, this is pretty thick, it's almost a 1/4 inch thick steel I had laying around, and I'm going to reinforce these where this joint is to keep it from, separating in and out. I've already done this one down here. What you're going to need, because you're going to be moving this thing around, it's going to be doing this all over the place, so you're going to want to get some nice heavy steel like this. It's a 1/4 inch steel. It's 3/4 inches wide, and I drilled it out, and so we're going to be tying in our corners. So these have been bent custom fit for inside each corner, and the outside where it's flat, obviously you don't need to bend it, and so what I do to get the angle on that, I use that sliding T-bevel, and it's best to measure each one because there may be slight variance, and these fit really well. And I'm using 2-inch metal roof screws. They're galvanized and they even have a washer on them, and they got a hex drive nut on them, which makes them drive real easy. Get it right about middle. Beautiful. Just goes right in there. That'll give it a lot of strength. But if you decide you don't need the wheels and that it's light enough, and it really, if you had 2 people, you could easily move this around. I would suggest though that you put this in, the reinforcing here, to give it some rigidity in the corners.
So here I've made some modifications, and I've got an eye bolt here that goes through the 1x that is supporting the corners, and that's for a tie down when the winter winds come along. Up here we've got the corner roof reinforced with 2 of the bolts that come with the kit that normally go into here, but I've used machine screws with T-nuts on the inside in order to tighten up in these big nice flat washers. We need this pod rigid because we're going to be moving it around. And over here I've got a machine screw. Now this is a 1/2 inch because that's what I had laying around, but a guy could get by with 3/8. And I've got 3 of them on the 3 corners, this one, the apex, and on the other side. This allows for a quick connection and quick disconnection of the roof so that you can lift it up and remove it. You could go to all the corners if you want, but for my purposes, I feel that 3 is enough on the windward side, which would be the opposite side over there. Okay, so here we have the lock, and you can't use a conventional hasp because the spacing is too wide. So I've taken 2 eye bolts with big flat fender washers, one on the outside, one on the inside, and then got this master lock, this big U-bolt master lock, and put that on there, and that works pretty good, and that'll keep the kids out, you know. I mean, so they don't go in there playing around, messing around, and gives you a little more security. And up here I put some caution tape because this is a little low, which is a good thing because we don't want this really tall. We want the scope to be able to see over the top of it. I also have the tape on the inside. Just a little something that makes that a little more visible so that when you're going in and out, you're reminded to duck your head. Now down here, this is a queen size inflatable mattress. And I find that these work really well. They're thick, they are waterproof, and they have a little bit of felt fuzziness here. And you want something like this on the ground. It acts as a vapor barrier and keeps the inside from having vapor coming off the ground. You really need this, or something like this that's going to be waterproof and act as a vapor barrier. But you can pick these up at a thrift store, but they're definitely nice. I use it typically out in the field, and they hold up really well. It's perfect for having it inside the pod. The windows come protected with a thin film that if you leave one of them on, the one that's going to be on the inside of the pod, it provides more dampening of ambient light from the outside. These are tinted because remember, this is a hunter's blind, so they are tinted, but if you leave that on, then from the outside you really can't see in. And also it cuts down on the ambient light. So when you're putting these in, if you want to have a little more privacy, keep one of those film strips on. Another mod I did, I put a handle in the center of the roof. Now that happened to be an old Celestron handle off the saddle, but a machine bolt will work just as well. I've got a big fender washer on the inside and a fender washer and rubber washer on the outside to make it watertight. Not likely it's going to leak because it's already got the bolt in there, but if it did, you didn't want it dropping dead center on top of your mount. Down here, I don't believe it was covered in the previous video segments, but the wall is screwed to the 2x4 using the same metal roofing screws, galvanized, with fender washers. And they're equally spaced, one there, here in the center, and then another one and another one. Pretty simple to do.
Okay, so let's cover the roof removal, which is certainly a key element here of this observatory pod. And I will say at the start that it is highly recommended that you have assistance the first couple of times you take it on and put it off until you can get a handle on how to remove it. It takes a little finesse, and once you acquire that, you might find that you can just do it on your own. Although depending on your health and strength, you might require assistance for removing and putting it back on. In either case, it's just a matter of taking the right approach and being cautious. The other thing I would add is on a windy day, it's probably not a good idea to be removing it on your own because the wind can catch this thing like a sail and either knock you to the ground or take it off and possibly create some damage or harm someplace else. So essentially what I do is I remove the bolts, go inside, and lift up the opposite corner that I'm going to be sliding it off to get it started, because you don't want it hanging up on that lip that it locks into. So you got to lift it up and get it off there. You slide it forward, and then you come outside, close the door, grab a hold of the edge, and wiggle it forward until you can get your hand on the handle in the center. And I highly recommend that you put one in there. And then from there, you gingerly lift it off. I had the missus help me the first time I put it on and took it off, and then after that I had a good idea on how to handle it and where to grab it and what to expect. And from then on, I've been able to put it on and take it off, and it's gotten easier over time. So like any of these things, practice makes perfect, right? Okay, so let's move on to measuring the inside and showing you some tolerances and clearances that you'll have if you decide to adopt this idea.
Okay, so let's take some measurements here so that you can kind of sort it out in your head on, you know, how your particular setup is going to work. So the base of the tripod, which would be right here from the floor, I have the legs extended in order to get over the top, is 33 inches. So it's 33 inches to the base, and then to the base of the equatorial head, it's 40.5 inches, okay? And then to the saddle, where the saddle plate is, it's 56 inches, okay? From the floor to where the saddle is, it's 56 inches. From the floor to the top of the scope is 68 inches. From the floor to the top of the scope is 68 inches. The north leg from the corner of the apex, and I'm including, I'll go to the actual vinyl itself and not the plate. It's about 10 inches away from the corner, the north leg. From the back of the saddle to the front, there's no problem with it hitting walls or anything like that. It's an 80 millimeter. It's 16 inches from here to here, and absolutely no problem. Plenty of clearance in that regard. So let's move it to where we will see about how long of a scope you could actually have here. And let's say you were imaging a target about like that. Okay. And that's about the angle. That's about, yeah, that's about the limit. That angle there is about the limit of what you can do. And according to the scale here, 10 degrees left of zero, more or less. Now, if you had a longer refractor, I'm going to go from the back of the saddle to where the wall would be. If you have a Schmidt-Cassegrain, then there's not going to be any problem. But if you're looking at a long focal length refractor, it could be a problem. I would say 27 inches from where your saddle is to where the end of a scope will be is about 27 inches is going to be maximum. But if you're using an 80 or a 90, then it shouldn't be a problem. If you're using an 8-inch edge or some kind of Schmidt-Cassegrain or Moxitov, you should be fine with those. It's been really great using this. It's been nice being in here out of the ambient light from the neighborhood, as well as the breeze and the wind. So that keeps the mount from, disturbing. And another point, a buddy of mine had asked me, well, how easy is it to tip over? What's cool about a pentagram, my prevailing winds come from that direction over there. So that means it hits these walls that are angled. But the wall that it hits, every flat wall has an opposing apex wall. So in other words, it has to push over the point. So it's not like a flat wall where it can just hinge on an opposite wall. I'm not saying, oh, you don't have to worry about that, because I have tie downs for the wintertime. What I'm saying is it's more stable than a rectangle or square building. That's what I'm saying. And this door here is on the east side because the prevailing winds come from the north and the west. That's why teepees on the plains back in the day, all the entrance doors were facing east, and the smoke holes or smoke flap was always east because the prevailing winds come from the west. So that's why I have this here, so the wind is not rushing in.
Well, that about does it here. If you found this information useful, consider becoming a member and subscribe. I got a long way back down there, so I better get going. Until next time, thanks for tuning in to Dakota Starry Nights. Clear skies.